Hi folks, last class you were asked to do these three questions, so look at each of them separately now. Okay, example 6, three lines are attached to a box and pulled in different directions. Find the net force. So you were just given the three forces. So force 1, 6 newtons east, force 2, 8 newtons north, and force 3, 10 newtons west and 50 degrees south. So it's up to you to be able to draw a scale net force diagram. So here's our box as shown. We have our force 1. So you draw your forces from the center of the object. So we have our 6 newtons east. We then have our force 2 and our force 3. And remember that's west, 50 degrees south. So the direction here's west. And you're going 50 degrees south, so the 50 would be here. And just let me write in the forces in newtons. And that was 10. Alright, you need to break this down into component forces. So what I would suggest that you do is make a table. But let's look at this as 3 steps. Step 1, your component forces. Step 2, we're then going to find the overall force, the net force. So 2. And step 3 will be find the angle. So I'll write that after, consider how much space we have here. So your net forces in the x and y direction. So force 1 in the x direction. So this force is 6 newtons east. So you don't need to do any calculation. The force is completely east. And east. Force 2. This force is completely north. So there is no west or east direction. So for force 2 it will be 0 newtons. And again, you can see it goes straight up, so there's no force pulling it to the west or to the east. Force 3. Now this one is pulled at an angle, so remember that anything in your x direction to get the component force. So force 3 would be your applied force times cosine the angle. So your force is 10 newtons cosine 50. And that should work out to 6 decimal 4 2 newtons. And that's west. Now let's look at our y component for each of those forces. And when I roll these, I should put x1. So force in the y component 1. So this force here is not going north or south. So it's 0 newtons. If you pull something straight across at the horizontal, then you're not pulling it north or south. If you want to do the calculation on that, if you doubt what I'm telling you, remember y component is force times sine of the angle, and if you said 6 newtons times sine of 0 degrees, you'll come out with 0. So your force 2, it's y component. This force again is 8 newtons north, and there's no left or right, so it's just 8 newtons. And that's north. And your force 3, we fix that. So the y component, force 3. Again, it's your force times sine of the angle. So 10 newtons times sine of 50 degrees. And it's 7.66 newtons, and that's going to be south. Now we need to get totals. So what's the total of all the forces in the x direction? So we're going to consider all these forces here. So you have 6 newtons east plus 0, so we're going to leave that one out, and you have 6.4 newtons west. Now usually I ask you, whichever one is bigger, you leave that direction alone and you change the direction of the smaller force. Well, let's say if you didn't do that. We went through a couple examples showing you to change the forces all in the same direction, starting with the biggest one. But let's say you decide to try differently. So 6 newtons east, and you say, sir, this force is east, that one's west, I gotta have them in the same direction. So you just went ahead and you changed this direction here to east. Okay, remember you just can't simply change the direction to east without changing the sign. So positive goes to negative. And if you add these two together, you get negative 0.42 newtons east. Now, when you want to draw this, drawing the negative direction is probably going to present a little bit of a problem for you. It's easier just to change it to a positive, so you want this number here to always be a positive. And it will be 0.42 newtons west. Okay, so we have the total of our west. Now we need to change, get the total of all of our y components. So you add these together. So you have 0 newtons for the first one, you can leave that out. Next one you have 8 newtons north plus 7.66 newtons south. Okay, now let's do this the quicker way. 8 is our biggest force, so we're not going to change direction on this one. South is our smaller force at 7.66, so we're going to change this direction to north, and by doing that you have to change the 7.66 to negative. So your total answer then is 0.36 newtons north. Okay, so your next step now is to get the net force. So you have a vector here and one here. We said last class you need to do vector addition. Does not matter which vector you start with. I normally start with the horizontal, but it doesn't matter. So you have one force, going west. So I'm going to change that and say like this. So it's going west, 0.42. And when you add your vectors, remember from the head the first, tail the last. And this one is 0.36. Sorry guys. And you draw your resultant vector going from your start to your end. And it's Pythagoras theorem now you need to use. So since I don't know the length here, I'll just call it x and use Pythagoras theorem. It's the other two sides squared and added together. And if you do this right, you should get x squared, 0.292, and then you have to take square root because this is x squared. and you get 0.54 newtons. So that's the size of the overall force. You need the direction that's acting in. And so this would be your third step, is to get the direction. So your direction is always theta equals the inverse of tan. Because from here, this is the angle you're finding, you have the opposite and adjacent. So tan negative 1, 0.36 over 0.42. So your angle should work out to 39 degrees. Now I know on the answers that I had posted earlier that it was 37. I didn't round some of my numbers as I was going through here. So if I had rounded these to 6.4, 7.7, it would have changed that. Now you need your overall answer. So force net is equal to, so you have the size of the force, 0.54 newtons. Now its direction, you're going west here and 39 degrees north. So what would end up happening to this box here is that it would, the overall effect of all three forces is that it would get pulled that way and get pulled in the westerly direction but heading 39 degrees north. And how much force is it being pulled with? 0.54 newtons. So everything you're doing here is just to add all three forces together and get the overall force. Alright, your next one. Two tow ropes are attached to a sled. The force of 300 newtons is applied to one rope in the direction of west 42 degrees north. And for your second one, it's 430 newtons applied to a second rope, which is west 61 degrees south. So our first force here is being applied in a westerly direction, but you're heading 42 degrees north. So that's our first one. And it is a force of 300 newtons. This one here is a force of 430 newtons. And you're going 61 degrees south. So the blue box is my sled. And perhaps just to make things easier, I just put in a set of dotted lines and crosshairs. So this is my compass. And I just put my forces on top of that. Now, again, you need to break these down into component forces. So you have X forces, and you have forces acting in the Y direction. So let's look at force 1. And again, forces in this direction. X, or your applied force times cosine of the angle. So in this case, it's 300 newtons times cosine 42 degrees. And that's going to work out to give you 232 newtons west. For your second force, the one here, green, it's 430 newtons. Cosine of the angle, which in this case is 61 degrees. And the overall force there, just in the X direction, is 208 newtons. And again, that's west. So both forces here go in a westerly direction. We look at the X components. And we need to get a total. So you add both these together, 232 newtons west plus 208 newtons west. And that will give you a grand total of 431 newtons west. And there's no change in directions here since both were the same. For the Y, 176 newtons. And even though it's straight down, we know on a compass that would be south. So for a total here, you're going to add your 201 newtons north plus your 376 newtons south. Now which is bigger? This one's bigger, so its direction stays the same, so you have to change to north. You change your smaller one. Directions have to be the same. So it's going to be a negative 201 south plus 376 south. That's a negative. So your force here is 175 newtons south. Then do your vector addition. Again, start with whichever one you like, it doesn't matter. Again, as I said, I usually start with the horizontal. So I'm going west. 431. Then I'm going to head south. And I'm heading south 175. So this was my start. So I draw, here's my net force. And Pythagoras theorem again. So x squared is going to equal 431 squared plus 175 squared. If you do the addition and the square root correctly, you should come out with a force of 465 newtons. So that's your overall force being applied. You also need a direction with that. I don't want to skip over to a new page, so sorry for making this a little cluttered, guys. So this was step 1, step 2, step 3, so 10, -1, and your opposite, which is from your starting point, your opposite is 175. Over 431. So you should have came back with an angle of 22 degrees. And I guess I should have said a fourth step in the last example. The fourth step is just give the final answer. Let me move this line here a little. So let's give the final answer. So your answer, you have 465 newtons of force. What is the angle it's being applied in? So start with your horizontal direction first, which is west. Remember to put it in square brackets. And it's headed south. And how much south? 22 degrees. So the overall effect here is that this sled is pulled south that way. But it's only not at 61 degrees, but it's going to be pulled at 22 degrees. Alright, we have one last example, and here I've given you a diagram showing the two forces. Here to a force 1 acts at 520 newtons north, 70 degrees north of east. So that will be here. So here's east, interacting 70 degrees north, and this second force is 210 newtons, 20 degrees south of east. The reason I stated the directions this way is because you're expected to be able to deal with the directions either in this format, or another way of saying this would be east and 70 degrees north. So these two are the same direction. You'd be ending up going forces. Make sure I give myself no space. X. And then Y. So force 1. And just so we're consistent, let's call this force 1. Call that force 2. So force 1 in the X direction. Again, you know it's force, the applied force times cosine of the angle. So the applied force is 520 newtons. Cosine of 70. And that's going to work out to give you 178 newtons. And if you look at your diagram here, that's going east. Second force, how much of that is going east? It's 210 newtons. Cosine of 20 degrees. Which is 197 newtons east. If you want, we'll jump right in. Well, not if you want. I'm the one here with the pen, so I'm going to jump in and do my total. So 178 newtons east plus 197 newtons east, square brackets, same direction, so there's no need here to change anything. So it's a straightforward addition, 375 newtons east, and boom, that was done. So you get your total there. The same or similar steps to get the Y. So I have this force here. How much is actually headed north? So it's the force that's applied. Cosine of 70. And that's 489 newtons north. And for the second force, direction here is south, so keep that in mind. So it's 210 newtons. It's only going 20 degrees south, so not a lot of this force is actually headed south. Alright, so there is 72 newtons headed south. Now you guys have to do your total here. So your total, you have 489 newtons. They're acting north. And 72 newtons acting south. So the bigger pool is north. So we don't change the northerly direction. Leave that alone. We change this one here. Negative 72 newtons. Change the sign. And it's 417 newtons north. Okay, now let's do your diagram. So step 2 is your addition. Step 3, let's get your diagram. I said that we would start with our horizontal force first. You heard that? That was my cat. Anyone who wants a cat, let me know. You're more than welcome to it. Now so you're headed east. It's 375 newtons east. Let's add in our next force, which is north. So from head of the first, we pull the tail of the last. 417 newtons north. So this was our start. Dotted line means you're going to find your net force or your applied force. And we use Pythagoras theorem. size, could use anything. PEQ, I don't care. So let's do this in one step. We're going to square both these numbers, add them together, and then take square root. So overall net force is 561 newtons. So we need a direction. And the direction is always from your starting point here. So it's opposite over adjacent, which is tan. So opposite is 417 over 375. Degrees. So your answer, you have an overall force of 561 newtons. Now which direction is it going in? It's going east